About is we're going to talk about a Taylor series or a Maclaurin series. And the series is written out for you here. This is the Taylor polynomial that we've been dealing with, right? And so all we did was write it out as a series, right? A series is a sum of a sequence. So we can see here that it's the nth derivative of c over n factorial times x minus c to the n, right? All we did was take this last term of the polynomial and write it with my series sign, okay? And if c is 0, the series is called the Maclaurin series. Any questions there? Should be pretty self-explanatory.
Are we going to deal with them as a sequence or
no? No. Sorry, I had to process what you were
I had
saying.
it for some reason, but I don't.
There you
Sorry.
go.
Thank you.
Okay, so there are three special Maclaurin series you must know. We've been talking about this, so let's go for it. Let's write them. E to the x, let's write a few terms, and then we'll write it as a series. Okay, so what comes first in e to the x? And remember, if you forget, you can always calculate e to the 0, right? And get yourself started that way. So e to the 0 is 1. Plus, and then remember it would be the derivative of it at 0, which is still 1. All of those derivatives are 1. So what's the next term?
X.
Just x. And then what?
Squared over 2.
Right? And this would be x to the n over n factorial. Oh, yep, thank you. And so then I will write this as what? The series or the sum from n equals what? 0. Okay, that's important. We've got to start this thing at 0, right? To infinity. And then all I've got to do is take that term, correct? X to the n over n factorial. Okay, sine of x. Sine is which powers? The odd ones, right? So if it's the odd powers, it's going to start with x because it's x to the first, right? So I'm going to have x
Minus.
oh yes, and it's alternating, right? So x minus,
60.
and then plus x to the 5th over 5 factorial. Okay, so let's write our general term. It's alternating, so I'm going to need what? A negative 1, right? I need to figure out what I need on the negative 1.
The n plus 1.
What's the x going to be?
to the n plus
What creates odd? What creates odd numbers? Either 2n plus 1 or 2n minus 1, right? Which one am I going to have in this particular case? The 2n plus 1? I guess, yeah, depends when you start it. Okay, so this will be 2n plus 1. And where am I starting this if this is the case?
0.
Starts at 0, right? So that might help you get going with what I need to have on the negative 1. I need the first term to be positive. And it's going to start at 0. So what needs to be on the negative 1?
N plus. Minus 1.
How about just n? Because it's going to start at 0,
Oh,
right? Because if I'm going to start this at 0, that's going to give me the x to the first. This is going to give me over 1, and that's going to make that positive. Okay, so you do have to take a little bit of time to, maybe think through that. But once we've come up with it once, hopefully you can, sorry, I'm like all down here.
Do you always want to start it at n equals 0? Like if you were to write it, say it's like -1 raised to the n like +2 and then start.
You can do that. For the most part, I see the series starting at n equals 0, like if it was in a multiple choice kind of question. But if you were supposed to write one, as long as your first term checks out, you're okay. Okay? All right, so how about cosine? We know that cosine is the evens, which means that it's going to start with,
2.
well, 1, right? Because it's x to the 0 power, right? Because 0 is an even number. So I'm going to have 1 minus
X squared
2 factorial plus x to the 4th over 4 factorial. And I know it alternates, right? So what do we need to put for the power? 2n, right? That's going to make it always even. And I know the power and the denominator will be the same. And then I need the first term. Well, where am I starting this one if I've set it up this way? At 0, right? So the -1 needs to be raised to the n power. Okay, so again, those are, I think you've got the Taylor polynomial part down pretty well. We need to walk in knowing the way they can, the series representation.
Is that another like numerous?
Yeah, I mean, really, it's just taking what we did and writing a general term for it. But the general term isn't too bad to remember. Okay, so let's do this. Find a Taylor series for f of x equals e to the 5x centered at c equals 2. Give the first 4 non-zero terms and the general term. Well, if I'm going to center it somewhere other than 0, what am I going to have to actually calculate? I'm going to have to find all the derivatives that I need, and I need to evaluate all of those derivatives at the center, right? Okay, so if it's not centered at 0, you're going to have to actually go and plug in stuff, okay? And this isn't, well, and I guess if it's not e to the x, that's the other kicker there, okay? So it wants the first 4 non-zero terms, so I would need to go to what power?
Could you show me
A third.
The third, right? Say again. Oh, yeah, I just have f of. Okay, so f of x is e to the 5x, right? So f of 0 is
1?
1. F prime of x is what,
E to the 5, e to the 5.
right? E to the 5x times 5. Yes, sir?
Should we be doing 2 and 3?
Oh, my bad. Sorry, 2, yes. So this is what? E to the 10th. Thank you. So f prime of 2 is what? 5e to the 10th. So f triple prime of x is what? Yep. Oh, sorry, spacing out. 25e to the 5x. So f double prime at 2 25e to the 10th. And remember, it just wanted the first 4 terms, so I only need
One more.
one more, right? So f triple prime at x,
25.
125
E to the 5x.
e to the 5x. So f triple prime at 2, 125 e to the 10th, right? Okay, so they want me to write the first 4 non-zero terms and the general term. Okay, so here we go. E to the 10th plus
5e to the
5e to the 10th
10th
x
x
minus 2. Everybody with me?
Yes.
Right? I'm just following my definition of a Taylor polynomial over there for now. Plus 25e to the 10th x minus 2 squared over 2 factorial. I need one more term. 125 e to the 10th x minus 2 cubed over 3 factorial. And then that's going to equal the sum
equals 0.
n equals 0 to infinity. Now we got to start putting things together, right? So what's in everything?
5
There's an e to the 10th everywhere, and there's an x minus 2 to the n over n factorial, right? And then I got to take care of that 5, right?
5 to the
5 to the n.
Yeah.
Yeah, we started at 0. You're looking cool back there, Jenny. I like it. I dig the look.
Such an awful.
All right, how we doing? You good with that?
Yes.
Okay, so what I have been alluding to as we have gone through the past couple of lessons is this idea that we can manipulate these 3 special series or any series we are given to find another series by using the following techniques. We can substitute into the series. We did substitution into polynomials, didn't we? For e to the x, we could easily do e to the 2x by just substituting in a 2x everywhere there's an x. We can multiply or divide the series by a constant and or a variable. We did that as well, right? We did, remember we did x e to the x, where we just multiplied every term of e to the x by x. We can add or subtract 2 series, and I don't know why I took that off of there. We can actually integrate and differentiate, and I showed you a little bit of that, didn't I? The other day? I'm not sure. Oh, it's because I covered it over here. Okay. Well, we might do one like that anyway. Okay. You know what? Go ahead and put this in here. Differentiate. Differentiate or integrate. Oh my gosh.
You gave up.
Yeah. We can differentiate or integrate.
And these are only for Maclaurin, right?
These are only for what?
Maclaurin. Or can you,
No, we can do them for the others as well.
so you can like substitute for a Taylor?
You can. I think what's going to happen though is like you would have, if you had that kind of problem, you would get like a base for whatever you were dealing with, like the one that we just did, and then it might come back and ask you to integrate or differentiate that. And it wouldn't impact you that much. I'll show you an example of what I mean. It is, you generally see this stuff more with Maclaurin though than Taylor. You are correct there. Okay, so find a Maclaurin series for f of x equals sine x squared. Find the first four non-zero terms and the general term. All right, so what's going to be our starting point here?
F of x.
What do we know?
That we have to do the third derivative.
Okay, what do we know we have to do first?
F of x.
Sine of x, right? Sine of x. You might want to, on your paper, write down sine of x first. Because when I do sine of x squared, what am I going to put in to sine of x everywhere there was an x?
X squared.
An x squared, okay? So that's what I'm going to do first. You don't have to if you don't want to. I'm going to write sine of x. And I've got x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. I wrote that many because it asked me to find the first four non-zero terms. So I went ahead and wrote 4 terms for sine of x. And then we said a while ago that's going to be the sum from n equals 0 to infinity of negative 1 to the 2n plus 1 x to the 2n plus 1.
No,
It's just negative 1 to the end.
Crap. Sorry. Thank you, keeping me on track today. I ran out of whiteout. That's never good.
You're the first person I've seen use the whitener, so if that's stressing.
I got another one. Negative 1 to the n. Now I'm good, right? There you go. Okay, so for sine of x squared, I'm going to have x squared minus x squared cubed over 3 factorial plus x squared to the 5th over 5 factorial minus x squared to the 7th over 7 factorial. And I'm going to go, and what I'm going to do is I'm going to leave it in this form. I'm not going to multiply the two powers together, because the more of that kind of stuff that I do, the harder it is to write that general term, right? So there's nothing wrong at all with keeping it in that form. So this will, all you're going to do is, in place of the x, insert an x squared. So I know that some of this seems repetitive, and that's probably a good thing because you need a little bit of the review anyway. And then it is, again, just adding the little series component to it. Okay, so which of these techniques did we do for this example? We did a substitution, right? So take a look at the next example. Find a Maclaurin series for f of x equals x cosine x. Find the first four non-zero terms and the general terms. What are we doing in this one?
Multiply.
Multiplying, right? So do that one at your table.
Maybe you turn around and talk to him. Actually,
Don't work with me.
Caitlin, you wanna work here? No, you wanna join us?
Why?
No, I can't come home on time
Can I help you work here?
and then there's a showing.
It's the same thing as the sine, but instead of 2 and plus 1.
Good for the cars.
Now he's good.
I mean,
No, you're just gonna multiply the entire thing.
Oh, it's
Just raise it up. Don't change it to now. I'm sure you did.
You could just add a plus one to.
Right.
Why don't you just add one to it? Why did you add it?
No, it'd just be 0. See, because it's 0 times 0. You're taking the 0.
You have to add a plus one.
Yes?
Just put a big X on the outside of the series.
You mean like when you're writing this part?
That right there.
This?
Well, I guess both.
Well, here's the thing though, is that they want you to write the first 4 terms. So in
Okay.
order to write the first 4 terms, you would need to distribute it.
Okay,
I mean, I get what you're saying,
Yeah,
but
it's
they
just-
would actually want you to attach it there.
okay.
Doesn't matter if you put that.
No.
I was
Yeah, two factorial.
like really lazy over the weekend.
Now, I will tell you this, if you were doing this one as a multiple choice kind of question, you do need to be able to get from there to there. Okay, so like when you multiply like bases, you add their exponents, right? So, but if you're doing free response, which the majority of these kinds of questions are in the free response, you're welcome to leave it just like that. Everybody good with that one?
How does that work again? Is the order like basis? Oh, I guess you put the X right.
You're right.
So you can just add whatever is there.
The exponents are. Okay, so look at the next one. What are we doing in the next example?
Adding or subtracting?
We're gonna add together 2 series, and then we're gonna divide, right? So we're gonna add, and then we're gonna divide. Was there a question on the other one? Anybody need help? Yeah?
I'm just wondering how you got that first term. You just took the derivative and then plugged in 0?
This?
Yes.
No.
Multiply one by
No. Remember, the whole point of this, James, is that I want to take the known series, cosine x, and I just want to multiply every term in it by x. I don't want to go through that whole process of taking the derivative and evaluating it at 0. You could. I mean, you could, and you would still get, and you would get this answer right here. But you want to try to avoid that, particularly because this is all timed. And when they ask you these series type questions, in order to work within your time constraints, you're going to need to be able to manipulate the ones that you know. Does that make sense? Okay. Did I help you, Jenna?
Oh, yeah.
Yes? Okay, all right.
Thank you.
Okay, so what do you want to do in this next one?
Do e to that factor.
Do e to the x. That's what I would do first. Let's do the e to the x. Let's do a few terms there. And I guess I'll do 4 terms. So that's 1, right? Plus x plus
X squared.
squared over 2 factorial plus
X cubed.
x cubed over 3 factorial, right? And that's x to the n over n factorial, right? If I was writing the series. Okay, now what do you want to write?
Write down each.
I would write down e to the negative x. Good plan. So I'm going to have 1 minus x, right? Plus x squared over 2 factorial minus x cubed over 3 factorial which is the sum from n equals 0 to infinity of negative 1 to the n x to the n over n factorial. It's just going to alternate. Yes?
Could you put the negative with the x?
Just negative x to the n.
Yes, you could do negative x to the n. Yes. Okay, so what line do you want to write next? I heard you say, Derek, what would you do?
Can you just add those?
Yeah, let's add them. Right, because that's, I need to add them and then I need to divide it by 2. And I need 4 terms.
Well, couldn't you just divide those by 2 and
I guess. Yeah, won't matter. Okay, so when you add them together, what are you going to get? 2. What's going to happen to every odd power?
Cancel.
It's going to cancel out, right? Every single odd power is going to cancel out because of that chain rule in e to the. I need 4 terms. I'm going to have 2, and then I'm going to have what? 2x squared over 2 factorial plus 2 x to the 4th over 4 factorial plus 2x to the 6th over 6 factorial. And then I'm going to go and do what with all of this? Divide everything by 2, right? And so now lose every 2 that I just put in, right? And I'm going to have 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial and that's a pretty easy series to come up with. It'd be the sum from n equals 0 to infinity of x to the 2n over 2n factorial. All right, how's that working out for you? Can't remember if I did this one in here. Can I turn this, well, let me tell you the ones I want you to do and then I'll raise that up. So for homework on the next page, there are some circled ones, but I'm going to modify it just a little bit. We're going to do 1, 3, 4, 5. You can scrap number 6. And we're going to do 7, 8, and 9. Okay? So let's look at these really quickly. Let's just talk about them real quick. So in number 1, I've got an e to the 2x and I'm centered at 3. What are you going to have to do on that one? You're going to have to, you're going to have to evaluate them, right? You're going to have to find the derivatives and you're going to have to substitute in 2, okay? Before you can come up with that one. 3. Sorry, I was looking there. You have to substitute in 3. Okay, well, I'll have to find all the derivatives and then substitute in 3. It'll be centered there. Okay, so for number 3, you will also have to find the derivatives and then evaluate it at 2/3, right? Okay, and you're having to do that because we're centered somewhere else, right? Not at 0. Okay. 4 and 5, these are Maclaurin series, right? So on this one, on 4, what would you start out with? Cosine of x. And then you would change that to cosine 3x using substitution. And then you would divide, right? Then I would divide by x. Okay, so similarly in number 5, you would start out with e to the x, do a substitution to figure out e to the negative x, which you can probably just go straight to that by now. And then you'll multiply every term by x squared. Okay, so look at 7. So this one says find a Maclaurin series for f of x squared. All right, what are you going to do there? Substitute, right? You'll start with sine of x, and in place of every x, you'll substitute an x squared. Now, part B says use your answer in A to approximate the integral from 0 to 1 of sine of x squared correct to 3 decimal places and justify your answer. So, do you understand that all you're going to do is take those terms that you came up with and integrate each term?
Yes.
Right? And then substitute it in, because it just wanted you to use the first 4 terms.
So we're only agreeing with first substitute.
Yes. Mm-hmm.
And then we would plug in the 1 and then subtract the
And then
entire
subtract what you get when you plug in 0. Exactly. Okay. All right. And then in 9, you're going to write the general one about x equals 2. Okay. So you're going to have to do some work there, right? You can't just you can't manipulate it. You're going to have to actually work it out. And then it asks you to find the series expansion for ln of x minus 1. And this is the one that I referred to the other day. How is ln of x minus 1 related to 1 over x minus 1? It's
derivative. I mean, antiderivative.
yeah, the antiderivative, right? So you'll have to integrate, okay? So I just want to make sure, we didn't necessarily do an example where we had to integrate or differentiate. We actually did, the other day I referred to this one, okay? So that's kind of that's the approach that you're taking. All right, so we actually have a little bit of time. Not a whole lot, but a little bit. So you can either start, you can